Okay, now today I will talk about the next generation optical fiber communication system, which is the optical MIMO transmission systems. And this talk has 5 sections, from introduction, optical MIMO example, current progress, future speculation, and the conclusion. Start from the introduction. As we know, with the development of technology from TDM to WDM and the coherent detection, the transmission capacity per fiber is increasing to about 100 Tbits per second. That is the current signal optical fiber input power limit due to the optical bandwidth limitation and the nonlinear effects. On one hand, it's very hard for us to break the number, which is 100 bits per second. On the other hand, the new 5G or 6G applications such as AR, VR, cloud computing require more data rate and the capacity. So we call this situation as a capacity crunch. To overcome this problem, we also need the new optical transmission technologies. So we borrow the concept MIMO from wireless communication to the optical domain, which means we will transform multi-channels in one optical fibers. And here is the typical point-to-point SDM transmission system, from the transmitter, multiplexer, SDM fiber amplifier to the demultiplexer and receiver and the digital signal processing section as well. In the optical fiber, we have the field model fiber or multimodal fiber and the multi-core fiber and the multi-core field model fiber and the ring core fiber to carry the orbital ocular momentum OAM signal as well. For now, we know the optical MIMO system, and here we summarize some current progress in the SDM transmission systems. And here we can say for the short-range SDM system in multi-core fiber, we can find that the maximum core number is around 37 or 38. And also in field model fiber schemes, the transmission distance will reach more than 100 kilometers. And the largest mode we can use is about 45 modes. Also, we have the long range SDM system, which means we will use multi-span optical fibers. And in those research, we can find that the transmission distance will have a great increase, and also the largest distance can reach more than 14,000 kilometers. And here we can say in field model multi-core fiber scheme, the larger capacity will have a shorter transmission distance, and also the field capacity will have a longer transmission distance, which means we will keep the transmission distance and the bandwidth balance. Okay, and for now we can say the development of the SDM fiber design, we can decrease the fiber diameter, and also we have the different schemes and the transmission capacities. And here we will decrease it to 125 microns, which is same to the single model fibers. Also, we make some comparison between the data rate and the spatial and the SSE in terms of the number of spatial channels and the distance. For SDM system, in the future speculation, we should focus on the smaller or more practical fibers, which means we need to design the SDM fiber to suitable with the current single model fiber. And also we will to make the integration and to build up the standardizations, which is very helpful for the commercial deployment of the SDM systems. So that's all. Thank you so much for your attention and any questions.
Thank you very much, Jiaqing Li.